Okay, welcome to the video for ContDataQC package in R. This is the introduction video. My name is Eric Leppo. I work for TechTech. The work was done through work for US EPA Vertebrae Wagon. The ContDataQC package is an add-in for R, which is a statistical programming language. Enables a user to perform some quality control checks and related functions on their continuous monitoring data. It's available on GitHub, which is a code sharing site, at the link below. To install within R, follow the code lines there. The force equals true makes sure that it always updates, and the build vignettes, a vignette is the overall help file, and that's equal to true to make sure that they get installed and created on your computer. Getting help from within R, make sure you load your library first, the command there. Then help with the specific functions, just prefix the function with the question mark. The help index for all the functions in the package is the command there is help package equals ContDataQC. The vignette, the overall help file, is there's the commands to call the vignette from the package, and it'll open up in a web browser. R, as I said, statistical programming language. It has many add-ins which are customized code and functions. ContDataQC is just one of those, and originally it started out as just a series of scripts but was modified to work as a package. Package is on GitHub, which is just code repository, makes it easier to distribute so that everyone can get access to it at any time. The R user interface is rather Spartan by design, so the use of third-party alternative interface, for example RStudio, is recommended. Objectives of ContDataQC is ensure that a minimum level of QC is performed on continuous thermal and hydrologic RMN regional monitoring network data. To standardize, speed up, and reduce missed errors in the QC process, standardize data for further analysis, and facilitate data sharing between entities. Core functions is to focus on the handling of continuous data. The main function is ContDataQC, and it has four parts. Get gauge data, which is, as you can guess, acquire data from USGS gauges, and it downloads it, puts it into a format that the package can use. QC raw data performs QC tests on data and then saves those. Aggregate creates a single file with a specific date range from multiple files, and it can combine or slice data from within files. Summary stats calculates summary statistics on your data, and each one of these functions generates a report, either in HTML or Word document. The quality control tests that are run are four basic ones. A gross range check looks for unrealistic values, so entries are flagged if values are above or below certain thresholds. Spike test looks for adjacent values that change by more than X amount. Rate of change looks for values that are change more than X standard deviations over a certain time period, typically 25 hours. Flatline test looks for values that are consecutive within a certain threshold, so say more than 10 values for temperature that are within 0.01 degrees C. The flags that are used is these are assigned to each data point and then overall to that data record from each test. So P is pass that test. Suspect, it was above a lower threshold but not quite to the level of failure. Fails the QC test if it's way over the limit or just over the limits that were specified that may be way out there. X is for no data or not applicable. Some of these tests need previous measurements to measure against, so say the first 10 records won't have a flat line test because there aren't 10 records yet for them to compare to. Just some examples down here. Failure of an extreme its water temperature gets flagged if it's over, let's say, 30 degrees C or less than equal to -2 degrees C. However, values close to that may be suspect, so values greater than or equal to 25 or less than or equal to -1 would be flagged as a suspect. Again, each of these 4 tests has a flag to it, and then overall, that record is flagged if none of the if for the 4 tests, at least one of them passed and none of them had a suspect or fail, that record gets a pass. If all the records were an X, overall it gets an X. If any one of the 4 tests fails, it gets a failure. If there are no failures and at least one suspect, then that record gets flagged as a suspect based on all 4 tests. Additional functions, there are a few other functions that were designed along the way to help out with maintenance of your data and statistics and looking at it. So comp site CDF generates some CDF plots for comparison of sites and or measurements from multiple time periods. The export IHA and the export stream thermal will export data in a format that's compatible with these other packages. Each one of those generates statistics based on stream temperatures or hydrologic flows. Period stats generate statistics based on a given time frame before a given date. So this is much useful for people with, say, biological samples that want to look at and see what was happening in the stream at given intervals before their sampling dates. Say 30 days, 60, 90, 120, 1 year. Rarefy would be used by those looking at biological samples with, say, benthic macroinvertebrates. If you're collecting from different agencies that have different protocols and they sample, say, different numbers of organisms. Say one group collects 300 organisms, the other one collects only 100. You may want to rarefy and subsample the ones from 300 down to a 100 count. It will not go in the other direction. You can't add organisms to a sample. RBI calc calculates the Richards-Baker flashiness index, and it'll just calculate on the data that it's given. So if you only want a 1 month measurement, you feed it 1 month. If you want a 1 year measurement, you feed it years worth of data. What the package does not do is it doesn't automatically fix your data. So you still have to go through the rest of the QC process and interpret why a measurement was either a suspect or fail. So that's why we saved all the flags. You can also add visual checks into your time series plots and figure out how to make corrections. So none of the corrections are automatic in the data. It just flags what it thinks may be where you have issues. And doesn't catch everything. We only have these 4 tests, so if you have ideas for other tests we should be running, just let us know. For files, R is case sensitive, so be aware when you're naming your files. Files for this package are assumed to be CSV files and in the format of site ID, sensor type, say air, water, gauge, start date, end date. Assume underscores in between, so that way the package can actually parse out the files itself. So dates should be in the format of 4-digit year, 2-digit month, 2-digit day. That's the ISO standard. So to install continuous data, you need to install R. If you're using RStudio, install that, and then install the continuous data QC from there. Installing R, there's the website. You may need your IT department, depending on the security settings of your computer, to get it installed. Same thing with RStudio. There's a link for it. Again, you may need IT department to be involved. Installing the QC package is fairly simple. Once you go through, I'll go through it in a little bit with some code. But generally, there's another package called DevTools, which makes it quite easy to get the package off of GitHub. Some general tips. Make sure you always load the package ContDataQC. If you try to run a function and it's not loaded, R doesn't know how to handle it. So use the command library ContDataQC at the beginning of all your scripts. Recommend, here's the website for GitHub, is you can follow the package on GitHub and get notified of any updates, and you have the ability to log any issues. Now I'm going to switch over to an art notebook, which is just a mashup of text and code. Again, all these slides will be saved on GitHub. So here's my window in R Studio. Here's my notebook. So here's my console window over here to the right. As I go through, here's my table of contents. In order to get up the vignette, always make sure you can just copy this out, put it into your console and run it. It'll pull up the vignette inside the help window in R, but you can also hit this button here to show it into a browser window. You can always list all the objects within the package. That'll show up inside your help window so that you can always scroll through and get to any of the functions to get to the help files. General quick description of each one of the functions, and each one of these you can always get to the help file. I have those help things here provided. I also have the links for the IHA and stream thermal packages. Switch back to PowerPoint. I just want to acknowledge that the work was done with funding by EPA, ORD. Project manager was Britta Bierwagen. My name is Eric Leppo, and the other people I had helping with this on the project were Jen Stamp, also at Tetra Tech, and David Gibbs, working at US EPA. Thank you, and goodbye.